Good evening. I've done my presentation on energy from fusion, primarily providing energy from fusion. First, we'll start with what is fusion energy. It is the generation of electricity by using heat from the nuclear fusion reaction. This process works when there is two lighter atoms that form a heavier one that releases the energy. And this is all done within a fusion reactor. This is what harnesses the energy. Some of the benefits of it: it's clean, it's a little bit safer, it's abundant, it's greener, it produces 0 carbon emissions. Just a little scale here: 1 kilogram replaces roughly 55,000 barrels of oil, 6 million kilograms of natural gas, and 10 million kilograms of coal. A little interesting fact there. This here is the inside of a nuclear reactor. See everything spinning around here. Some private fusion companies have high hopes to commercialize this industry by 2040. The hopes are that if fusion energy is achieved and matured, then lower costs will follow. Many cost-effective ways are examined. However, it will be several years before anything will come about. And there's another interior of a nuclear reactor. Some of the key findings: the energy markets are very competitive in regard to resources and cost effectiveness, and electricity is a commodity which it can be traded because it's a raw material. Process heat may be a difficult early market for fusion, as it is a hyper-localized market to which fusion power plants must be tailored. Retrofitting, repowering coal plants have the potential to save 30% of the capital cost by reusing many of the balance of plant components. And there's one more for us on the outside. Let's see here. Economic boost. The code generation specifically deals with the feasibility of fusion energy and what other perspectives can be taken. Desalation is the use of energy to remove salt from water to produce suitable drinking water, or for farming or agriculture, just in general. Can be a solution to worsening water shortages. Currently, there are two main types of direct air capture technology: a high temperature liquid solvent method and a low temperature solid sorbent method. Both are very similar, as they both require heat and some electricity. District heating is the main source of heat to buildings, producing steam or hot water. And here's where some of the atoms get together, form a little reaction. So, lower capital cost is the big idea. There are many things to consider when moving forward, such as the construction costs and what happens if the project is unable to be completed. It is noted that overnight construction is typically what is quoted, ignoring the total cost of the project, which causes a substantial issue. Another issue is the financial risk and possible bankruptcy. But however, there's one cost-effective way to go, and it's reusing equipment such as the already existing coal plants. And there we go. So in summary, although this paper examined this within today's market prices, there's a lot of room for growth and improvement. Adjustments and new scenarios will be made in the coming years, which will allow for a new perspective on fusion energy. It is key for developers to focus on high-priced electricity markets while also integrated thermal storage as another source of energy. It is noteworthy that fusion plants could potentially increase revenue via cogeneration, such as distillation, direct air capture, or district heating, and could lower capital costs such as reusing the coal plants.